Okay, good morning, everyone. I'm just going to wait for a couple of minutes because it's not exactly quarter past yet, and I'm not sure where some of you guys are when you're tuning into this. So we'll just wait for a few minutes in case other people need to arrive. Okay, I think I'll start. So my name is Dermot O'Connor. Now, in previous years, I would have met you mainly in third year. I used to teach a module called Web App Dev 2 in third year, but I didn't last year with G, as you might remember. So I haven't met any of you before, but we'll get to know each other during this semester, hopefully. So you got my email and you've tuned in, so that's good. And I guess I'm just going to get going, really. So what you have access to is can I just check first of all that you can hear me? Somebody might acknowledge that.
Yeah, we can hear you.
Good. Right. Yeah, so you have access, I've given you access to this website, and I think you've seen this style of website before. You certainly saw it with Frank and whoever was with Frank Walsh when he was teaching Web App Dev 2, and you might have seen this layout in earlier years as well. So all of my material will be published on this particular website, and this will grow as the semester evolves. And as I think I mentioned to you in the email yesterday or the day before, actually, maybe Tuesday, maybe, we only use Moodle for assignment submissions. Now, I have received emails from some of you and about the Moodle side of things, and thanks for that. Thanks for letting me know. It seems there are problems with people accessing Moodle. I'm not too concerned about it because we won't be using it for a couple of weeks, actually. I do need to resolve it, though I'm not sure if the issue is that the people that manage the Moodle system aren't allowing self-enrollments, or if it's a problem with the way I've set up the self-enrollments, probably the latter. I have made a change to one of the settings, so maybe you might just try and access it again using the link that I gave you and use the enrollment key, and you might get in. And if not, maybe those people that emailed me yesterday might come back to me. I don't need to receive 40 emails from all of you. So maybe there's those people that emailed me yesterday might just come back to me if you're as to whether you can get into Moodle or are still having problems. And if there are still problems, then I'll talk to the other people that manage that system to try and resolve it. But as I said, I'm not too concerned about it initially anyway. So let's go into now. I hope you had a good day yesterday, but I'm afraid I had a terrible day yesterday because my laptop, which I use for everything, just crashed and it won't work for me and it's out of action. So I've had to try and transfer stuff over to another machine, and it's been problematic for the whole day of yesterday and this morning as well. As it turns out, they're my woes. So I'm hoping all this goes reasonably smoothly. When I'm not on my own machine, as you might imagine, you're just not too sure. You're missing software that isn't installed and all this kind of stuff. But hopefully I can get through this 2 hour lecture now without any major hiccups. So I want to go in here and I want to just work my way quickly through these slides, which is fairly lightweight stuff, really. And I'm also going to turn off my camera. I have the slides here, so you can just follow along with the screen reader rather than accessing the slides yourselves. So the title, Distributed Systems as a module title, that's been around a long time. But I've included the AWS logo on this opening slide because that's really going to be front and center of everything that we do in this module. Now, Distributed Systems as a module title predates cloud. So that's why I kind of say the title has been around for a long time, but as to what one covers in this kind of module has also changed over time. But right here, right now, certainly cloud would be a central part of it, and it is in my case. This is going to be a very practical based module. I hope that's something that's that you enjoy rather than being too theoretical. There has to be a little bit of theory, I guess, but it's predominantly practical based, which is why there are 2 labs per week. In terms of trying to set a context, this is how I see the context from your perspective anyway. So what I'm trying to get across here is that this module on the right is really linked to 2 other modules that you have covered, both which happen to be in 3rd year. And I've used a kind of a thick or a broad arrow connecting distributed systems to DevOps. And I've used a slim arrow connecting it to Web App Dev 2. And what I'm trying to get across there is that there are much stronger links with the DevOps module, which hopefully you remember from the 1st semester of last year. There's also a link with Web App Dev 2, and that'll become apparent as we work our way through this module. But certainly it's the DevOps side is more dominant in terms of setting a context. And as you might remember, DevOps was all about introducing you to, well, not introducing you because he had covered AWS, I think, in an earlier year in another module as well, as far as I'm aware anyway. But certainly DevOps was very much AWS focused and cloud focused. So that's where the link is with my module. The Web App Dev 2, if you remember what went on there was he developed a web app which comprised of a front end using the React framework and a back end or server side using Node and Express. It's the server side or the back end part of that module. We'll kind of revisit that, but we will deploy it, I suppose, onto the AWS platform, but deploy it in ways that you wouldn't have seen heretofore. In DevOps, if you, for example, you might remember, for example, you would have spun up EC2 instances, and you might have installed a web server on the EC2 instance. We won't be using EC2, but we will be deploying web apps onto AWS. So we'll be using some other services that are not as heavyweight as EC2. So anyway, that's kind of the context. The first bullet point in this slide, I literally just extracted this from the module specification. Now, module specifications, I don't know if you ever looked at the specifications of the various modules that you covered in preceding years, but sometimes they can be quite abstract and maybe not very understandable to you. Hopefully they're understandable maybe at the end of the module, but you're not interested in looking at them at that stage. But the first bullet point, I just took straight out of the module specification, the introductory part of it, I think, because it does inform us, as it should, I guess, as to what distributed systems is going to be about. And I've underlined architecture, the architecture of modern distributed applications. Like if I go back again, referred to the web API, the back end part of the web app that she developed in the Web App Dev 2 module. You might remember it was a REST web API. Now, some of you might have actually, as well as running that web API locally on your machines, some of you may have actually deployed it onto some cloud service, maybe Vercel or something like that. You might have done that as part of your assignment. But you would have deployed it onto the cloud service as a single unit, as one entity, if you like. So in a sense, that web API, it didn't have an architecture. Okay, technically we would refer to the architecture as a monolith architecture because it was just one big chunk of code deployed as a unit, probably onto into a Docker container running on top of an EC2 instance or something equivalent to an EC2 instance. You wouldn't have been aware of what was happening underneath when you did the deployment. But the point I'm trying to make is that the architecture of the web API that you developed back then, in a sense, it didn't have an architecture, although technically we would refer to it as a monolithic architecture, meaning that it was just deployed as a single unit. Whereas that's not really the way we deploy server-side applications in real life. In real life, we break them up into components and we connect those components together in certain ways. And that set of components and how they're connected is what we would refer to as the architecture that we're interested in here in this module. So we'll see some contrasting or alternative architectures for essentially server-side code. Two in particular we'll be looking at. We'll be looking at a serverless architecture, which is really kind of a microservices architecture, and we'll be looking at an event-driven architecture. So these terms will become second nature to you by the end of the module. The other thing I've highlighted in that first bullet point is that, okay, we'll be developing some functionality, although functionality is not really what we're mainly interested in. What we're interested in is architecture, which I've already mentioned, and deploying that architecture. Obviously, we develop it locally, but we want to deploy it. And as I alluded to, we will be deploying it onto the AWS platform. But we want that deployment not to be something that we have to do manually, that we have to type a whole series of commands from the command line. We'd like that deployment to be automated. So deployment and architecture, I think, would be the two key recurring themes throughout this module. The last part of the sentence, I'm saying it's for a constrained set of requirements. All I mean by that is, our applications are going to be, our server-side applications are going to be quite small in terms of the volume of functionality. We can't be dealing with big applications because we don't have enough skills and knowledge to deal with large-scale applications. We'll be dealing with small applications, but still we'll be learning about architecture and deployment and automation of deployment. So they're the kind of skills and knowledge that we want to have at the end of the module. In terms of the key themes there, which kind of draws from the first bullet point, one theme that runs right throughout the module, after about week 2 from there onwards, is infrastructure as code. Infrastructure, as you might remember, certainly would have been mentioned in the DevOps module that I referred to. Infrastructure is so we have our server-side application. We've broken it up into components, and those components are connected to one another in some way. The infrastructure then is the cloud services that we use to deploy this architecture onto. Now, as I said, we don't want that deployment to be a manual thing. What we we want to automate it. And as it turns out, what we can do is we can describe the infrastructure of the cloud service that we want to have provisioned or created for us. And also we can describe how the different components that make up our application are deployed to the various infrastructure elements. We can describe all of that using code. Code as in our case, we're going to be using TypeScript, which is a form of JavaScript, but we could use it we could have used Python, Go, Java, many other languages. So we'll actually be writing code, the purpose of which will be to deploy an architecture onto a particular cloud platform, in our case, the AWS platform. Heretofore, the only link you can make, or the only association you would have with this notion of writing code is, well, we use code to implement functionality. But here we're going to be using code to describe the infrastructure that we want to have provisioned on the AWS platform for the purpose of deploying our application architecture. Bit of a mouthful. Although I think maybe infrastructure as code, or IAC for short, again, that would probably might have been mentioned in the DevOps module. You may have done a tiny bit of infrastructure as code. You may have used CloudFormation. I didn't check which Richard Frisby would have taught you that module, whether Richard covers CloudFormation with you, but either way, I'm not assuming you have done anything like this before, although I am assuming that you're vaguely familiar with CloudFormation and you are very familiar with some of the other services, the AWS services. Serverless, I've already mentioned, it's a kind of a model stroke architecture that we'll be looking at. Scalability, anytime you deploy stuff onto the cloud, scalability is always a concern. We've all probably heard about the furore, was it 2 weeks ago, with the Oasis tickets and selling an online kind of sale scenario where there's high volumes of traffic hitting a website, but really that website is backed up by some server-side functionality. And sometimes that server-side functionality doesn't scale very well. Despite, there were so many problems. So, we will be referring to scalability every now and again when we work our way through this module. It won't become a big part, but I will mention it every now and again because it's always an issue when you're deploying anything to the cloud. Architectures then, which I've mentioned many, many times now, but two architectures that we look at, apart from the serverless, which I'm saying serverless is an architecture, or strictly speaking, I suppose it's more a model rather than an architecture. But the two architectures that I will talk a little bit about are the microservices architecture and the event-driven architecture. And we will get to implement the second of those two in the kind of the third or the last quarter or last third of this module, at the back end of the module. The microservices architecture, we're only going to talk about that because we would have to cover something called containerization in order to realize a microservices architecture, and we don't have time to cover that. I mentioned there about using code to describe the infrastructure that we want our cloud platform to create for us. Well, for no particular reason, the code or the language that we're going to be using in this module is TypeScript. A lot of people would not necessarily associate TypeScript with infrastructure as code. I could have used Python and many other languages, but I'm going to plump for TypeScript in it. And I think you'll enjoy becoming familiar with the language. And it's not a huge jump. You certainly have a lot of JavaScript in your toolbox. So going from JavaScript to TypeScript isn't going to be an issue. And TypeScript would be quite kind of related to Java as well in its nature. Talk more about that in a while. I'll just pause for a second, just in case there are any questions from you, and feel free. The way I deliver these lectures, I do just tend to keep on talking and demonstrating. But feel free to just butt in at any time and raise a question if you have a question. Every now and again, I do pause, but are there any immediate questions? Not necessarily on the actual slide that we're looking at right now, but if there are any kind of housekeeping issues or startup issues with this module.
You're mentioning that we need AWS accounts.
Mhm.
Are they going to be similar to what we have with DevOps, where they were a student account with €100 or whatever on it, or do we have to buy our own?
Yeah, great question. Unfortunately, it's the latter. I tried working with the type of accounts that he would have used with Richard in the DevOps module, but the problem with those accounts is that they're not sufficiently privileged to allow us to do the kind of things that we want to do. So you will have to create, people will have to create their own accounts, which means providing either a credit or debit card. But I am very conscious of costs being incurred, and I will be reminding you at various stages to, having deployed something, to undeploy it. Well, it turns out, right, that, for example, if we go back to that serverless theme there that I talked about, one of the nice things about deploying or provisioning serverless infrastructure is that you don't incur any costs unless the infrastructure is being exercised. And we won't really be exercising the infrastructure that much. What we're interested in is deploying it and checking that it has deployed or provisioned properly. Okay, doing some basic testing of it, but as if the infrastructure is just sitting there and we're not using it, we won't be incurring any costs. Unlike, for example, if you spin up an EC2 instance and it's sitting there and not doing anything, you still are incurring costs, as you will know from last year. But for the serverless services that we'll be using, there'll be minimal costs. I wouldn't see anybody. Hopefully, I shouldn't pick a figure, but I mean, I wouldn't see anybody incurring more than, I don't know, maybe $20 in the entire semester. But the short answer to your question is you're going to have to create your own AWS accounts. And that's what we'll be using. Anything else, I wonder? No, okay.
Yeah, there were some questions in the chat.
Oh
One of
yeah,
them is that are the labs going to be in person or online?
I'm terrible for keeping an eye on that, and I don't tend to do it. Would the people prefer to just speak out the questions? Maybe don't have microphones, but let me see. Can I bring up the chat? I think I'm going to have to stop sharing for a start.
I can read them out to you if you like.
Pardon?
I can read them out if you're unable to get to the chat.
That would be brilliant. Go for it.
Yeah, sure. So Sam Taylor asked, are the labs going to be in person or online?
Because of the issues that I'm having with my the technical issues that I'm having, initially they're going to be online. Then they will be in person. But the way my labs work anyway is I will publish the labs on the website. Let me just jump forward to where do I go to? I'm going to here. Let's go to this topic. So here's a typical lab. And again, the kind of style and layout of these labs are similar to the labs that you would have done in Web App Dev 2. And they're written in a way, hopefully, they're kind of self-instructed, you can work your way through the lab without having necessarily me to, to do a demonstration of something first. So you can work your way through these labs on your own, and really in the lab hours, that's what you will be doing. Okay, I'll come along at the very beginning of the lab and I'll allow you to either ask me questions at the beginning, but if you're having issues as you're working your way through the lab, you would need to come up to me and show me what's happening, send me screenshots I use Slack quite a lot. I should have mentioned, or I was going to mention at some stage, there is a Slack channel, workspace that I need to invite you to. Again, it was one of the things I had planned to do yesterday, but because of the technical issues that I had, I couldn't get around to it. So we will be using Slack for all our communications once I get it up and running and you have joined it. We'll be using Slack instead of email predominantly. And I'm happy for people to send me Slack messages, even if they can't make the labs. You can send me Slack messages as you're working your way through them. During the lab hours, you can send me Slack messages outside of the lab hours as well, but I can't guarantee that you'll get an immediate response, whereas you will during the lab hours. So the answer to the actual question is that they will be in person, but not for, I'd say, a week or two until my technical issues are resolved.
Okay, and there's just one more question. How soon should we get these AWS accounts?
Immediately.
Cool.
Immediately. I won't be using them next week, but you will be using them from the week onwards. So you do have a little bit of breathing space, but creating an AWS account is a short enough task, really.
Thank you. That's all the questions.
Great. We've had that. Let's go. I think, am I sharing? I am sharing, yeah. Okay. Prerequisites, we've just been talking about them. You need an AWS account. You need to install the AWS CLI on your local machine, which you probably have already from DevOps. I'm just listing them here just for completeness. You need to have Node.js installed on your machine locally, which you will have from Web App Dev 2. And don't really care about what version of Node.js. It doesn't have to be the newest, shiniest, up-to-date version. Anything from about version 18 onwards. Although having said that, when I installed Node version 20 on my replacement computer yesterday, it was causing some problems for me, but I have a workaround, so I can explain what the workaround is when it comes to us using Node.js, but you will need Node.js anyway. I use VS Code, which you would have also used in the Web App Dev 2, so you probably have that installed. If for whatever reason you don't like VS Code, that's fine. I don't care what editor you use, but I use it in my lectures when I'm demonstrating stuff. We use Git a lot, so you need to have the Git tool installed locally. You need to have a GitHub account, which you should have. Everybody should have at this stage, and you need to re-familiarize yourselves with JavaScript if you haven't done any JavaScript in the last 6 or 8 months. You need to also re-familiarize yourself with the management console, the AWS management console. You would have used that a lot in the DevOps module. We will be using it to check that our infrastructure that we have described using code, when we deploy it, we need to check that stuff has deployed properly. So that's what we'll be using the console for. But again, as I said, be comfortable navigating around the console. They do tend to change it slightly every now and again. So there may be slight changes in the layout of it from when you were using it in the DevOps module. The stuff, boring stuff, 2 hours lectures, all online, 2 labs. We've already talked about that. It'll be online initially. And by online, I mean, yeah, we'll be communicating over Slack, and I will, as I said, I will send you an invite via email within the next day or two so that you can join the Slack channel. If you did happen to speak to any of last year's 4th years, and maybe the topic of assessment comes up, as it always probably does with students, understandably. So the module is still 100% CA, but the way I'm assessing it this time around is different from how I assessed it last year. But the main difference is the last bullet point there, the lab-based exam, which is going to be worth 50%. That's going to happen, I think, in week 13. So we can talk more about that, later on if we need to. There will the lab work is worth 10%. It turns out now that the first lab, which is all TypeScript, I will require you to submit that, and that will be worth a certain percentage. There may be 1 other lab, maybe maximum of 2 other labs that you will submit during this semester. I don't want to overload you too much with submitting lab work, so that's why the percentage is small. But it just turns out that the very first lab, which you will be working on now over the next week and a half, really, depending on how much stuff I get covered, really, in the lectures. So there's no mad rush with concerning ourselves about lab work submission for now. 2 assignments, roughly, each worth 20%. And there will be, one will be on the serverless architecture, and the other assignment will be on the event-driven architecture. The lab-based exam will hopefully cover everything or most of what we've done in the module. The resources, the website you know about, Moodle we know about, although we have problems with it. And I should have added to that list of resources the Slack channel as well. Any questions about that slide? No, okay. This is just a screenshot from the website from last year. And I'm not going to change the content dramatically from last year. So you can see essentially, if I take it from the left to right, we're going to spend a lecture or 2 covering the TypeScript language. Then I'm going to introduce you to a framework stroke tool called the, where's my mouse gone? Called the Cloud Development Kit, or the CDK. The CDK tool is what will allow us to realize this infrastructure as code idea that I mentioned there earlier on. And we will be using that CDK tool right throughout the entire module. So we need to get comfortable with it from the outset. Then I'll talk about the serverless model. We will be deploying constrained set of requirements applications or small applications onto a serverless platform, the AWS offerings. Then I'm going to talk about, in theory, I'm just going to talk about application architecture. That's where I'll talk about the microservices architecture and the event-driven architecture. So that's this card really is, the card is probably on proportion in terms of the time that they consume. Serverless will consume maybe 3 weeks, CDK, week and a half maybe. The application architecture will hopefully, I get through it in 1 double lecture. If I can, it may extend a little bit beyond that by 20 minutes or 30 minutes. And then the card to the extreme right is where I talk about implementing the event-driven architecture idea. So in the mouse keeps this appearing somewhere in this section here. I'll talk about the microservices architecture and the event-driven architecture from a just theoretical point of view. And then in this section here, that's where we will implement miniature event-driven architectures. And there'll be an assignment on that, as well as an assignment on the serverless topic. I've titled this one here on the extreme right. This is one of the aspects now of this new computer that I'm working on. The mouse just always goes back to the top right-hand corner. This here, the section here, will be, you know, about 3 weeks. The serverless section will be about 3 weeks. And so there'll be an assignment on each of those. So they take up a good chunk, but both of them will be based on using the CDK tool, which is this infrastructure as code tool. So that permeates the entire module, that CDK tool. The card on the bottom there is where I'll publish all of the lecture recordings. Any questions on that? No? Okay, let's go back to, God, this mouse is really annoying me. Let's go back to this section here. Well, let's switch over to the actual website, because that's only a screenshot that we're looking at. So what do I need to do? I need to stop sharing for a start. Just give me a minute now. Okay, so moving on to this topic now. I'm going to walk my way through these slides. I'm not going to get through them all today. What time have we got now? It's no, okay. So I'd say these slides will take us into all of next week as well, I'd say. But let's get going in it. So I wanted to talk about, give a quick kind of introduction to the TypeScript language. Some of you may have actually played with the language already. That's great if you have, but I'm not assuming you have. I am assuming, though, that you are very familiar with JavaScript. So you may need to just refresh your knowledge of that. So these are the slides that are published on the website. And I will be, now and again, I'll be switching from the slides over to VS Code, just looking at sample code. And the sample code you can get by cloning the GitHub URL that I've provided there at the bottom of the screen. So you can clone that later on. This is kind of what I call the marketing slide, which we will have very few of. So The TypeScript language was developed by good old Microsoft. They get a lot of bad press, but they actually produce a lot of good open source stuff as well, including VS Code. So the language has been around since about 2010, 2012. That's I know a wide gap there, but they were working it for, I guess, a number of years before they open sourced this. The individual that is the main creator of the language, has a good track record. I'm not sure how you pronounce his name, Anders Hejlsberg. I'm not sure if that's right or not, but same individual that designed the C# and Turbo Pascal. So some pretty impressive credentials. The TypeScript language, obviously, it's based on JavaScript, and what we always say is that it's a superset of JavaScript, which means that if you just write pure JavaScript, the TypeScript compiler will actually accept that and will run it. Not the runtime will run it, but JavaScript would be considered badly written TypeScript, and we'll see what that means maybe a bit later on. From a specification point of view, the TypeScript language I'm saying there in the third bullet point was based on ECMAScript 4 and ECMAScript 6. ECMAScript, you might remember, is the specification for the JavaScript language. JavaScript language actually has a specification which some languages don't. So whenever we talk about ECMAScript, we're talking about the specification for the JavaScript language. And this specification has evolved over the years. And they're just called ECMAScript 1, 2, 3, and I don't know where we're at now. They changed around 2015. 2015 was ECMAScript 5, but then they started calling the subsequent ECMAScript specifications, rather than calling them 6, 7, 8, 9, 10. They also kind of refer to them by their year. So we talk about ECMAScript 2015, ECMAScript 2016, ECMAScript 2017, and so on and so forth. So the TypeScript language, the creator used ECMAScript 4 and ECMAScript 6 as the basis for designing the TypeScript language. And I'm telling you there further on in the slide that where ECMAScript 6 comes in is TypeScript has classes. It's a class-based object-oriented language. JavaScript, as you know, at its core is not class-based or object-oriented at all. Strictly speaking, it's kind of a functional programming language. But the JavaScript community wanted classes introduced into the JavaScript language. And so the organization that manages this ECMAScript specification, which is called the ECMA organization, they eventually gave way and they added classes to the JavaScript language, but at its core, JavaScript doesn't understand classes at all. We can write class-based object-oriented JavaScript, but that actually has to be transpiled or converted into plain old JavaScript, which knows nothing about classes. Unlike Java, for example, the Java language has classes at its core. It's built into the runtime, but JavaScript does not. Yet we can write class-based object-oriented code in JavaScript simply because it's probably the most common programming model out there today. But so we can write it in JavaScript, but it's still converted back to non-class based at runtime. TypeScript leverages that aspect of what we might call modern JavaScript. So we have classes and all that follows on from classes in our TypeScript. But as well, what TypeScript has, which JavaScript, whether it be class-based JavaScript or non-class-based JavaScript, what TypeScript has is it has a type system. JavaScript does not. JavaScript is a dynamically typed language, which means when you declare a variable, you can assign any type of value to that variable. You can assign it a number, you can assign it a string, you can assign it an object, you can even assign it a function. So the same variable can be assigned different types of values. With TypeScript, that's not the case. TypeScript is a typed language. TypeScript is a statically typed language. JavaScript is a dynamically typed language. I've already explained what dynamically typed means in the case of JavaScript. In the case of TypeScript, which is the exact same, for example, as Java or Kotlin, in those cases, which are statically typed languages, when you declare a variable, you have to state the type of values that can be assigned to that variable, and you cannot assign it values that are not of that type subsequently. Now, the JavaScript community tried to introduce that into the JavaScript language, and where it tried to do it was in the ECMAScript 4 specification, which is quite a long time ago, actually, about 2008, 2009, maybe. But it never caught on. It was never realized in the language itself. Okay, the specification is there, but it never transferred over into actual implementations of that specification. But in the case of TypeScript and the creator of TypeScript, he actually went back to that ECMAScript 4 specification because there was lots of good stuff in it, and he brought all of that typing, static typing, into the language. Right. This bullet point here, I'm saying, okay, we write TypeScript code, but at runtime, that TypeScript code has to be converted into plain old JavaScript. There's no such thing as a TypeScript runtime environment. It's only a compile time concept. So we always have to transfer it into JavaScript, but there are tools that do that for us, and that's what we run. TS is compiled to, TS is compiled. Oh yeah, to regular JavaScript, and that's okay. Need to hold time on the slides right now. What are we saying here? Okay, just a comment from Bernard Ike. Who's Bernard Ike? Does anybody know? See this name here? God, sorry, no, my mouse, it just keeps disappearing on me. Just give me a second. See this name here, Bernard Ike? Does anybody know who Bernard Ike is? Bernard Ike is the individual that designed and created the JavaScript language. There you go. So even though he is the creator of the JavaScript language, his comment in TypeScript was this one here, that the really nice thing about TypeScript is this thing called type inferencing, and I'll explain what type inferencing means in a while, and you will see as well that type inferencing is really a fantastic aspect of TypeScript. If it wasn't there, it's highly likely if type inferencing wasn't built into the tools that we use, then the TypeScript language may not have caught on as much as it has. Another individual, I'm not that familiar with this person actually, but he's obviously a guru in the web development world. His observation was okay. When we write TypeScript code, we've got lots of typing, as not typing as in physical typing, but we have to type or declare the types of our variables and any other of our data and our functions and classes and all that kind of stuff. We have to declare the typing information, if you like, but that typing information is thrown away when we actually compile it into JavaScript and run the JavaScript. It doesn't actually, you don't see any type-rated detail in the JavaScript code that is created from TypeScript. And his observation is that that is actually a good thing, which is probably true. The TypeScript language was really came about for the purpose of managing large-scale applications. If you're only writing applications that are quite small in terms of line of code, then arguably you don't really need TypeScript at all. JavaScript is fine. But when you've got a large code base, and the larger the code base, the greater the possibility of people misinterpreting the purpose of certain variables that are being used and passed around the place, misusing them. But with TypeScript, you can't misuse a variable. By misuse, I simply mean assign it a value that assign it a type of value that it shouldn't be assigned. Anyway, right, the TypeScript language, is it popular? It certainly is, and that graph there shows you, this is a graph of the top 10 programming languages that are being used on the GitHub platform over the years. And you can see the TypeScript language, has started from essentially zero because it's only been around since 2010, 2012, as I said. Most of the other languages listed on this graph predated, but TypeScript has found its way to position number 3, and that hasn't changed this year. Okay, let's get into the mechanics of it. TypeScript, the file extension is .ts, it's fine. There are also files, source files with the extension .d.ts. In these files, we declare the various types that we are using in our source code. So in TS files, that's where you put your functionality, if you like. That's where you have your classes and your functions and all that. In the .d.ts files is where you can declare the various data types that are being used in your functionality. You don't have to have these .d.ts files. You can declare your data types inside TS files as well, and I think we do every now and again. But you can keep them separate. .d.ts files are similar to header files, if any of you are familiar with header files from C and C++. Where these .d.ts files are also used heavily is, I'm mentioning in this bullet point here, third one. You see, okay, we're writing TypeScript, but JavaScript has been around for a long, long time. And there are tons and tons of JavaScript third-party libraries, in other words, the kind of JavaScript ecosystem. And we would like to avail of those third-party JavaScript libraries in our TypeScript code. Now, in order to do that, though, we essentially kind of have to make all of that JavaScript code. We need to enforce a type system on that JavaScript code, and that type system, where you can achieve that is by including these .d.ts files in the third-party libraries. And so the creators of various third-party JavaScript libraries have augmented them with these TypeScript declaration files, so that we as TypeScript programmers can actually use those third-party libraries. And we will see lots of that going on as we work our way through it. It'll be there kind of in the background, but that's how we are able to use third-party JavaScript code in our TypeScript projects. Where these declaration source files are also used a lot is in the tooling that we use around TypeScript. Because as we'll see, when we're writing TypeScript code, we get lots of hinting and IntelliSense built in to whatever IDE we're using, in our case, VS Code. Well, what that tooling is actually using to provide hinting and to provide IntelliSense, what it's doing is it's using these declaration files to help it. So again, that's kind of going on in the background. Any language has some core types built into it. And of those core types, a subgroup are the primitive types, and the primitive types of the TypeScript language are all the ones that you would expect any modern programming language to have. So it has numbers built in as a primitive type. Booleans are built in as a primitive type. Strings, of course. The null is built in as well, which we're familiar with from Java. And hopefully everybody is familiar with undefined. This comes from the undefined value, really comes from JavaScript. You know, in JavaScript, if you declare a variable in JavaScript and you don't explicitly assign it a value, then the JavaScript runtime assigns the undefined value to that variable. Because TypeScript is built on top of JavaScript, that undefined value is still available to us, and it's still part of the TypeScript primitive type set, if you like. Apart from these primitive types, everything else is classified as an object type. And they are the kind of things that we are familiar with. Classes, modules, interfaces, they're all categorized as object types in TypeScript. Like on the next slide, if I just jump forward for a second, I just grabbed this slide a week or two ago. I just found it and I thought it's kind of nice, really, and it's informative. What it's telling us is, here's the type system that is a type hierarchy, I suppose you should call it, that is built into the language. Now, there are many parts of this hierarchy that we won't see in our case, and that's fine. But part of the hierarchy is mentioning the primitive types that I've just been mentioning there. So the Boolean type, which really it borrows from JavaScript, the number type, which it gets from JavaScript. This isn't present anymore, so we can ignore that. The string type I mentioned, null comes from JavaScript. Object comes from JavaScript. Arrays come from JavaScript, and functions come from JavaScript. But I don't know whether you know or not, but functions are actually implemented in JavaScript as objects. Most people would not know that unless you dig deep into the language. Also, most people would not necessarily know, not most people, but a lot of people wouldn't necessarily know that arrays in JavaScript, I'm talking about JavaScript now, right? Arrays, they look as if they're built into the language, but they're not actually. All they are objects behind the scenes. We tend to, when we talk about objects in JavaScript, we think of, you know, for example, JSON instead of key value pairs. But it turns out that arrays are actually implemented using this kind of object underlying structure behind the scenes. We treat them as arrays in the normal way, but internally they're actually they're stored in memory as objects. That's just by the way, okay? So everything that I've underlined there comes from JavaScript, but okay, there's a nice little hierarchy here, but all of the other boxes in this diagram, they're all isolated from one another. Here's the undefined, of course, that comes from JavaScript as well. Now, sorry, that one there. What TypeScript has, it's kind of tied all of these together. to form this hierarchy, and at the top of the hierarchy is the any type. Okay, there is this other one that's above that. We don't see this unknown type, even though it's actually quite a useful thing. But I'm just focusing on the any type. So if you have a variable, and if that variable is a Boolean, or a number, or a string, or an object, or an array, it can be treated as a variable of the any type. Okay, and if I go back to my previous slide, I'm saying there at the very bottom that the any type, all types kind of inherit or is a subtype of this any type. So the any type was just introduced so that we have this kind of hierarchy. And we do see it popping up every now and again. So that's why I'm just mentioning it there. So I know all this stuff is a little bit abstract for now. Let's try and get something tangible. So the first thing about the TypeScript language from a syntax point of view is that we declare the type for a variable using this postfix syntax. And again, if you've done any TypeScript programming, you'll know this already. So if we look at this example here, the let keyword we know from JavaScript. So I'm declaring a variable. The variable's name is me. And here's the TypeScript specific stuff, right? So this is my postfix, and here I'm saying that the me variable, its type, its data type is string, meaning that the only values that I can assign to the me variable are string variables. And that's what I'm doing on the right. Okay, so this postfix is the syntax for how we assign a type to a variable. Now I'm just going to flip over to VS Code. And what I'm showing you in VS Code is the contents of the GitHub repo that you can clone for yourselves. And we'll just quickly work our way through this. So if I start up at go into the source folder and into the 00 folder, basics, and then if I open up that, there's a file called index.ts. Okay, .ts. And voila, here we go. Simple declaration of a variable. Here's another variable. Its type is number. Now, I've commented this line out here, and if I uncomment it, like so, then the first thing I'm showing you now is as much a VS Code thing as it is a TypeScript thing. So you can see here that this line now has got a kind of an error underlining happening in it. And also what you should always have open in VS Code is the problems tab, which we see down here. And the problems tab will show you what syntax errors you have in the file currently. So it's telling me, if I just move this over, it's telling me that the type string is not assignable to type number. And indeed, that is correct, because I declared this variable here as being of type number, but here I'm trying to assign a string to it, and clearly it doesn't like that. So straight away, we can now see that this language, this TypeScript language, is very sensitive to data typing or typing information. So I'll uncomment that. Now, in JavaScript, I know I've mentioned that already, but I'll just repeat the point. In JavaScript, it won't complain about those two lines of code. Of course, in JavaScript, you wouldn't have the type declaration. You wouldn't have this stuff. But in JavaScript, you can declare a variable, assign it a value, in this case, a number. And on the very next line, or anytime subsequently, you can assign a different type of value to that variable. And the JavaScript runtime doesn't complain. Unless, of course, you've got code subsequently that is using this variable and is using it as it's expecting it to have a numeric value, but certainly it finds that it has a string value. And that may well cause your JavaScript to crash depending on what the line of code is doing. But you don't discover that until you run the JavaScript. Whereas in TypeScript, you're informed of it straight away as you're literally creating your code. You never get to the runtime stage. And that's as simple as that is the source of many, many headaches associated with the JavaScript language for large projects, trying to debug why your application crashed. In many cases, it's because you are treating a variable as if it has a value of one type, but in fact, its value is of a different type. Now, clearly, you didn't need to resolve that, but that's the source of many of the issues with the JavaScript language. And that, in a nutshell, is why TypeScript came about at all. Okay. And if I now comment out this line, then my problems tab or panel is now happy. So you're always keeping an eye on this as you're writing TypeScript code so that you can fix your errors as you're working your way through it. Okay, this line of code is fine. This makes sense. It makes sense to use the plus operator on a variable of type number. If I try to do that with a string, clearly that doesn't make any sense. But to repeat the point, if I did try and do it with a string, add one to a string in JavaScript, it might actually do something, all right. It may not crash, it may do something, but it certainly doesn't make a whole lot of sense. And again, that's another aspect of the JavaScript language. Sometimes code which shouldn't really run, it doesn't make sense. It does actually run successfully. Eventually, it'll cause problems, but in TypeScript, you just can't get away with that. If instead of using my nums there, I used my string, then it's going to complain, or it may complain. As I think about it, maybe you might actually get away with that one, but it's just the odd case. That's fine. Now, I suppose the other thing that we'd like to know as beginners is, okay, how do I run my code? And in the README, I tell you how to do. So let's open up the README. I tell you, this is how you, let's see. Of course, you have to run npm install at start because this is a node project that we're using here. I'm telling you, this is how you run your TypeScript code. And really what's happening here is two things. It's actually compiling your TypeScript, and then it's running the output of that compilation. What is the output of the compilation of a TypeScript file? That's a question. What does the compilation of a TypeScript file, what does that produce? What does it generate? Generates a file. What is in that file? Anybody brave enough? What's in the file produced by the TypeScript compiler is JavaScript code. How do we run JavaScript code? We run it on the Node platform. So what I've highlighted here, what that command does two things. It compiles your TypeScript file. You tell it what file you want it to compile. It compiles it, and it then takes the output of that compilation and runs it on the Node platform. Now, I did tell you at the start of this lecture, I had a lot of problems. My own computer crashed and I had to transfer everything over or as much as I could, as quickly as I could, to another machine. And so here's one thing I found when I tried to do this yesterday. So if I copy this, I'm kind of making excuses for myself now, but anyway, you may encounter this problem. Let's bring up a terminal. Close this a little bit. There's my command. And I want to run the 0, I need to go all the way down, so it's src 0, 0. And index.ts. You don't actually need the index.ts. If you leave it out, it just goes looking for a file called index.ts anyway, and it crashes. There's something wrong. And this is a problem I had yesterday. Now I'm using Node version 20. What version of Node do I have? Yeah, Node 20, which is pretty up to date, but I think we're at version 21. But it doesn't work. On my own computer, okay, I was using Node version 18, that's something. The command worked fine. So I didn't get around to fixing that problem yesterday, but I have an alternative. And so the reason I'm actually showing you this is you may encounter this as well, although I do want to fix that problem because it should really work straightforward enough. But here's an alternative approach to doing what I wanted to do. So if I now take this command, and so if you have the same problem that I'm having here, this is essentially kind of a workaround for now anyway. So if I repeat, if I take that, copy that, this is really the old way of doing it, but and it's doing the exact same thing. This command, it's compiling it and then running the JavaScript output on Node, because you can see the command there begins with Node. So we're going to src 0, index. Now the warning message at the beginning there is, we can ignore that. Actually, that's just telling us that this is only a kind of an experimental way of running TypeScript code, so we can ignore that. But the stuff that's outputted in white is this stuff here is generated by the various console logs in my code. So the very first thing it outputted there was a 2. Where did they get the 2 from? Go back into my code. It's from this console log here. Okay, I initialized it to 1, and then I bumped it up. So that's where we're getting the 2 from. So so the really important thing though is, if the first command for running, it may well work on your installation. If it doesn't, then use the alternative approach that I've just demonstrated for you there. Any questions? Didn't really anticipate this issue arising, but it arose for me yesterday, so it may well arise for you. Let's move on. What else? Oh yeah, I'm saying there's excellent IntelliSense. Can we demonstrate that? Yeah, if I uncomment this line here. Again, I'm getting an error message down here. Let's see. Sometimes the error messages are great. Sometimes you might be scratching your head a little bit, but it's saying property to uppercase does not exist on type number. Mouse over it, you'll get the full text of it. So I'm number here. or sorry, this variable is of type number, as we saw at the beginning there of the file. But to uppercase is not a method that you can invoke on a numeric value. What do you tend to call to uppercase on? What type of value? What type of variable to uppercase, do you think? I'll ask it another way. To uppercase is a method associated with what type of variable? Is it a Boolean? Is it a
String,
number?
isn't it?
Yeah, exactly. Now, if this was a string, and I do have it, so if I just change it to my string, then it's happy, right? There's no compilation, and it will run as well. The point I'm trying to make is that the IntelliSense, here, the IntelliSense is actually taking, sorry, the IntelliSense is leveraging, in our case, in this particular case, it's leveraging its knowledge of that type system, right? But it's, and we'll see later on, we'll see that IntelliSense will be useful when we have our own types, because we can add our own types to this hierarchy. And that's what we spend a lot of time doing. These are the built-in types that we're seeing here. So it's just that the IntelliSense, that's the point I'm just getting across really. I know now this is kind of baby stuff, so just bear with me. The reason this, so the reason this underlying there, that's not an error research, that's just that's VS Code telling you that, look, you've declared this variable, but you're not actually using it. Yeah. And clearly that's not a sensible thing either, but it's not going to cause any compilation errors. It's just telling you maybe you should get rid of it or make use of it somewhere else. Okay, my code is happy. Let's keep going. As well as the primitive types that I've shown you, there are some other types that are built into the TypeScript language. They're not mentioned on that hierarchy that I showed you. One example is the regex type, which is for regular expression. So regular expressions are built into the language, and I'm assuming people have come across regular expressions before. I'm not going to explain this code. Go back and look at it. Look at this code yourselves, and if you're struggling with it, then by all means come to me and I'll explain it. So we'll just move on from that. Arrays, let's go back to my slides. We have arrays in TypeScript are what are called typed arrays, which means that when you declare an array, you have to declare what are the nature of the values in that array, what type are they, and they are the only types of values that it will allow you to put into the array. So for example, I'm saying here that the mynums variable, it's an array. This here is the syntax for telling the compiler that really this variable is actually an array, and the values in the array, their type is that. And you can see on the right, that's what I'm actually putting in there. If you put in an actual something else in here, if you put a string or a Boolean, then you'll get a compilation error telling you that's not consistent with how you declared the array. Now this type, so this is the type annotation related to arrays. You can and many often need to use typing when you're declaring functions as well. So we've got a simple example here of a function, and here we're declaring the types of the parameters to that function. And as you'll see later on, you can also declare type that is returned by the function. I'm not doing it in this case, but in many cases you do need to. Back to my VS Code, I've got some demos of arrays, even though I'm probably overdoing it really. Let's see. Arrays, is there anything interesting here? Okay, this is another way of declaring the array type, this kind of angle bracket and close angle bracket and the keyword array, and the thing between the two angle brackets is the actual type. Strictly, so the syntax that I'm showing you here now is based on something called generics. If you've done any Kotlin programming, which I think you would have done in Persia, I'm not sure if you've done. Have you done any Kotlin programming? Programming in the Kotlin language?
No, we haven't done anything like that in college.
Okay. Well, if any of you are doing the Android modules, are you doing an Android module this semester? No, you're not sure.
Yeah, we are.
Yeah, well, you will definitely come across the Kotlin language, and Kotlin uses this this type of syntax a lot. Kotlin is a typed language as well as it's a statically typed language. It's not dynamically typed, but it uses this the syntax as well, so you come across that. But anyway, in TypeScript uses it. So it's just this syntax is just an alternative to that syntax. And in fairness, most of us would use the one that I've just highlighted because it's less physical typing. And just to bore you further, if I try and fool the compiler, then my compiler complaining. All right, you can see. It's complaining because I've put a value into the array that's not of the proper type, and it's telling me that straight away. Again, you don't get that in JavaScript. Right, let's move on. Something new. Classes are available in the language. I'm not going to spend any time. You've done a lot of class-based programming even way back in first year, and everything that you know about class-based language is also available in TypeScript. So I'm just going to skip over that because, as it turns out, even though we'll do a lot of TypeScript programming in this module, I don't think we use classes at all, as it turns out, or very minimal amount of it. But they are available in the language, as they are available in JavaScript. Interfaces are available in the language, and we're very familiar with interfaces from all the Java stuff that you've done. So we don't need to cover that. Now, there is a concept called interface data types as well. Not sure why we use the term, the word interface in these. It's unfortunate because they are kind of similar to interfaces in the traditional sense, but interface data types are more related to data objects. And I'm telling you there in the first bullet point that an interface data type tells the TypeScript compiler, sorry for reading it now, about the property names and their values in an object. And it's saying that any instance of that particular interface data type, it must have the properties that are mentioned in the interface data type. Here's an example of an interface data type declaration. So I'm essentially declaring a new data type for myself here. The name of the data type is person, and I'm saying it's a person variable. It's going to be an object that has two properties, one called first, one called last. And here are the types associated with those properties. Here I am now declaring an actual variable. The variable's name is me, its type is person, and the value that I'm assigning to the me variable is consistent with the structure that I've defined up here. And again, if you try and if I left out the last property, if I omitted that from here, the compiler is going to complain. Or if I try and add a property that's not in the interface, the compiler is going to complain. Switch back to the code. Okay, there's my person there. This is an example now of something that rather than putting it into a .ts file, which is what we're looking at, we would tend to put these declarations into the .d.ts files. Because we have so few of them, I'm just leaving them here for now. Although I have a .d.ts file later on. But for now anyway. And there's the me variable. And again, like I said, in case you think I'm making this up as I go along, if I comment out that, so I should get rid of the other error. I put the other error up here. Okay. Yeah, if I leave that out, sorry, then the compiler complains, and you can see the bottom of the screen. Essentially telling us that there's a property missing. And also, even though this is a very simple example of an interface data type, what's really nice about TypeScript as well is that as you are writing your code, it's actually kind of helping you. So what I mean by that is, I just get rid of all of this for the moment. Okay, so I'm creating my me variable, my me object, and I start typing, and maybe I don't remember all of the properties in the person structure, but IntelliSense would help me. So I start typing, and you can see here it's actually prompting to me. Maybe it's one of these things now. Okay, then I realize, oh, that's the one I'm actually looking for. Or in the case of last, it's even better. It's the first one that pops up. So that's the IntelliSense that is using the declaration, which is just up here. It's using that to help you as the developer to write correct code. In JavaScript, I could put any kind of property in there, and I'm not going to discover until runtime that maybe I've omitted properties that I should have put in there, or I've added properties that shouldn't be there. That again is what's really nice about JavaScript, about TypeScript. For large applications where there would be many, many interface data types and you just can't keep them all in your head at once. The IDE or editor helps you. Also, if you try and extend the me object like here, yeah, I'm going to comment that. I'm getting an error down here. The error I'm getting is because it's telling me you don't have a property called address on an object of type person. With JavaScript, it just lets you do that and it doesn't complain. So that's interface data types. And we'll see a lot of those as we work our way through this module. Type aliases is, it actually overlaps, type aliases overlap with interface data types. But type aliases also allow you to do stuff that you cannot do with interface data types. So interface data types on the previous slide, that is a way of defining new data types for your application outside of the ones that are built into the language. In our case, the person data type. Type aliases allow you to do the same thing. They allow you to create new types in your application. And so that's why I'm saying it overlaps with interface data types. So if we look at an example, I've got 3 examples here. If we look at this example here, right? The syntax looks like this. It's the type keyword, the name that you want to give to this type, and then the structure of the type. In this case, it's a structure. Now that is exactly the same as what an interface data type does. So that's where they type aliases and interface data types overlap. And it doesn't really matter which style you use, whether you use interface data types or type aliases. Here's another example though of where we can use this notion. Well, let's look at this example here, sorry. Here's an example of where we use this type aliasing syntax. And what I'm doing here is I'm defining a new type, which I've called alphanumeric. And what it says here is that an alphanumeric variable can be a variable that has a string value or a numeric value. And here's an example of a variable that is of that type. In the num variable, I'm saying its type is alphanumeric. And by assigning it the value 10, the compiler won't complain because I have defined alphanumeric as being either of type string or number. Whereas in the next line here, I'm declaring a variable called string or str. It's also of type alphanumeric, but I'm actually assigning it a string value. And there are occasions in real life when variables could have a mixture of different types of values. But rather than leaving it completely open-ended, what's better is to define a type alias for those types of variables and be specific about the different types of values that apply. So I'm not including Boolean here, or I'm not including regex. Okay, it's only string or number. So that's one use case for type aliases that you can't achieve with interface data types. Strictly speaking, this is what is referred to as a union type. Here's another use case for type aliases. And the way, okay, it's beginning again with the keyword type. What some people kind of are confused with initially with TypeScript, if you've never seen it before, is that you need to understand the difference between declaring a type and declaring a variable. When you declare a variable, you assign a value to that variable. When you declare a type, you're talking about the structure for that type. You're talking about the nature of the values that instances of that type can have. Okay, so there's declaring types and there's declaring variables. Variables have values. Types are more about structure or the nature of the values associated with the type. Okay, having just said that, this now seems to be confusing, but anyway. Here I'm declaring a type called, in my case, pet category. And I'm saying that any variable of that type, it can only have the values this or this or this. So this is very like an enum in Java, if you remember enums. Okay, this is what's known as a literal type alias. And here I'm declaring a variable. I'm saying its type is pet category, and I'm assigning it the string dog. And that's, the compiler is happy about that because my type alias said that only cat, dog, or goldfish can be assigned to any variable of this type. But type aliases, checking my watch. Do we have anything interesting in the source code? Let's take out that. Sorry, I'm trying to remember what I was trying to demonstrate here. It's okay. Okay, just going back to the interface data types, here's, a slightly more elaborate example, where one of the properties, this one here, its type is a string array. So it's, it's extremely flexible. Here's examples of an object of that type, and it's consistent. And, again, if I start putting values into this array, for example, if I start putting, I'm going back now to interface data type, sorry about that, but if I put any value into this array that's not of type string, then the compiler is going to complain because that doesn't match up the declaration here. I think that's all I'm getting at there. Just more stuff with interface data types. Should have covered it earlier on. So I've got a semester result. Okay, and then I've got another interface data type here, and this property here, kind of interesting. It's actually an array of interface of semester results. So we can use arrays not just with primitive types, we can use arrays with our own custom types. Here's a variable that's matching up with all of that. And at the risk of really boring you now, if I uncomment this line here, the compiler is going to complain because the structure here is name and grade, whereas it needs to be module name and grade, because that is the structure of a semester result. If you go back up in the flow of the code there, so the compiler can drill down into objects as deep as you want, and it will catch any misuse of your type system. Okay, and moving on to type aliases then. Okay, here's your kind of standard type alias, which looks exactly the same as an interface data type. So what am I declaring? I'm declaring a course. And here I'm using the type alias to define a type called academic entity, which is either of type course or CAO student. CAO student was something that I declared higher up in the in this source file, and that was declared using the interface data type syntax, whereas this was declared using the type alias syntax. You can just see it up here, right? But there's no problem with that. That all compiler is happy with all of that. And you can have as many options here as you want. It's not always just two options. You could have another R symbol followed by a type and so on and so forth. And declaring an actual instance of academic entity. And you can look at the detail. Well, okay, so this is, in this case, I'm assigning student X. And if you remember, student X from earlier on is an instance of CAO student. So there's no compilation issues there. Example of function. A function which takes an argument of type academic entity. Function doesn't do anything interesting, although academic entity now, as we saw, academic entity could either be a course or it could be a CAO student. So presumably in the body of this function, you know, we need to determine, well, is the parameter that was passed into me, is it an instance of course or is it an instance of CAO student? It has to, because presumably the processing that it's doing is slightly different. There may be some common processing between the two, but at some stage there will be some part that is different. And that's all I'm doing in the if statement here. Let's see. So I'm checking to see, does the parameter entity contain an instance of a code within it? And if I think course is the only one that has the code property, whereas CAO student doesn't. So if it comes in here, what it's dealing with is a course, whereas in the else case, it's dealing with a CAO student. And that statement there, that condition, that's just plain old JavaScript. Remember? Let's see what else. No, it's all okay. Right. Cover type aliases. Although we will come back to type aliases later on. What's next about TypeScript? Type inferencing. This is what Bernard Eich mentioned about the TypeScript language that he liked. Type inferencing is where you can actually omit adding the type annotation to your variable declaration. The compiler will actually work out what type the variable is based on the value that you assign to it. So in many cases, you don't actually have to physically include the type annotations at all. If we did have to always use our type annotations, it's likely that the TypeScript language would not have actually become as popular as it is, because we would, as a developer, you just have to physically type too much code and your productivity is impacted by that. Simple example is being demonstrated here in this line of code. I'm declaring a variable called a string. I'm not using the type annotation syntax. I am assigning it a value of type string, and the compiler will infer from this statement that the type for this variable is a string type. And it will carry that information with it down through the rest of your code, and it won't allow you to do any assignment to the variable that is not of type string. Now, what's appearing up here is what's being generated by IntelliSense again, and I can just demonstrate it to you. I go back, and this is something that you may be using quite a lot actually as you kind of work your way through this module. So if I go back to the very first statement that we have here, and if I get rid of that, and we can see in my problems, okay, compiler isn't complaining. Now, if I just land the mouse on the variable, now you can't see, but I am typing, I'm going to type a command sequence, which is Command K, Command I. I guess if you're working on a Windows OS, it's Control K, Control I. So if I go Command K, Command I, you can see what pops up there is typing information for me about this variable. It's telling me that its type is string. Yeah, and so two things here. One is the aspect of the language, the support for type inferencing, which means you do not have to physically include the type annotation in many cases in your code. The compiler will infer the type for you. And the second point I'm making is that with VS Code anyway, okay, if you mouse over a variable, and it doesn't have to be at the declaration stage, any subsequent stage, if I go down to, where do I use it? I use it somewhere, surely. Well, I use it here. Yeah. If I go Command K, Command I again, you know, it's telling me that's the type of the variable. So the IDE is just helping me there. But the overarching point is this idea of type inferencing, which is built in to the language, or built into the compiler, really, let's say. Okay. Oh yeah, and in this second screenshot, I'm saying that, or I'm demonstrating that this type inferencing can drill into a reasonably sophisticated line of code and infer types for you. So in the example that I have here, okay, I'm declaring an array of person objects. And here, as you may remember from your JavaScript, here's my array, and I'm calling the filter method on this array, and I'm passing it a callback. You've done all of that before. But in terms of type inferencing, I'm not stating over here what type this variable is. Now, and the reason is because the compiler will infer the type for me. It knows that the filter method, when applied to an array, what it returns is an array of values whose type is the same as the values in the source array. And if I did Command K, Command I on that, which I think I have it, that piece of code in the project. Sorry, typing inferencing, where are we? This is type inferencing. And here we go. Here's my friends array of persons. And if I mouse over this guy here, Command K, Command I hit that command sequence. It's interpreting it as, as an array of, or sorry, it's inferring that it's an array of person objects. So type inferencing can work through, it's not hyperly complex, but it can walk through this statement here and work that out for me based on its knowledge of that method. And I talked about, okay, filter is part of the array type in the JavaScript language. The filter method comes from there. But somewhere built into the TypeScript runtime, there is a .d.ts declaration of this filter method and what are the parameters that it takes, what types of parameters does it take, and what types of values does it return. And the compiler and VS Code is leveraging all of that to infer the type for that variable for me. Similarly, in the callback that I passed the filter, like I'm not stating here, I'm passing it a function, a callback. I'm using the arrow syntax, which you're familiar with, but I'm not saying what is the type of that parameter. But again, the language will infer it, and I can prove that by going Command K, Command I on that. Okay, so that's this notion of type inferencing. And the consequence is we don't, as developers, we don't have to write all of this type annotations. Sometimes you have to be explicit, sometimes you don't. And then you try and avoid it. You try and let type inferencing take care of it as much as you can. Functions also are subject to all of this typing layer that's built into the TypeScript language. I've already mentioned that the parameters, when you declare a function, you have to declare, in some cases anyway, you have to declare the types of the parameters, and that's what we're just demonstrating here. Also, you may or may not have to declare the type of the return or what is returned by that function. And here's how you do it for a standard function definition. So that's type annotations applied to the return value of a function. And that's consistent with what the function does in terms of what it returns. So the compiler would be happy with that. Turns out that type inferencing, you can actually leave that out. And type inferencing will infer, based on the return statement, it will infer that the return type is a number anyway. But I am being explicit about it. And I think you will find as novice, if you don't mind me referring to you, novice TypeScript programmers, you will probably use annotations in many cases where you don't really need to. The type inferencing would have taken care of it for you. And that's fine. I don't remotely expect you to be kind of sophisticated TypeScript developers by the end of this module. Quite can often infer, that's the point I've just been making. Okay. Right, as usual, I never get as far as I think I might get in the lecture. I'm going to stop here and we will pick up the story next Thursday. So the lab, if I can, just before you tune out, if you've not already tuned out, I go over to the lab. Based on how much we've covered, you can actually start into the lab and you can do this section and you can do this section, interface data types, which we've talked about. Functions we've talked about. I think you'll be able to do some of that section as well. So you can certainly get started with this lab and go as far as, certainly as far as the interface data types section, and have a look at the function sections. I've forgotten what I put there now. I'm not sure whether you'll be able to do any part of it or not. Don't worry about, I do say at the very beginning of this lab that you need to submit it. Don't worry about that for a while because we haven't resolved the Moodle issue. And I will send you an invitation to a Slack channel either later on today or tomorrow, and we'll communicate over Slack in Monday's lab and in Tuesday, Wednesday. I think it's Monday and Wednesday is when I have labs with you guys. Okay, I'll leave it at that. I'll pause just in case there are any closing questions. No, all right. Thanks for staying with me if you're still there. And I'll touch base with you by email later on this week. Bye-bye.
Thanks.
Thank you.